In this video, we're going to talk about solution concentrations. Let's talk about exactly what is a solution. So a solution is simply a homogeneous mixture, okay? It's a homogeneous mixture. And if you think about what exactly is a homogeneous mixture, it's basically you have a number of components. At the very minimum, you need to have two components. So the components, they're mixed together so that the whole solution it looks the same. So it's uniform. So uniformly mixed. Now it's not just about uniform mixing, but it's about when the components are mixed, you can't distinguish the components from each other. So for example, if you take sugar, you add it to water, at the very beginning, you can see that the sugar is actually, you'll see the crystals and the granules. And then the water, you can see it very separate. You add the sugar to the water, you see the sugar at the bottom of the water. And then when you mix them together till all the sugar dissolves, now you have a clear solution. And it looks like just the water, but if you taste it, it'll be sweet. So therefore, that's a solution. That is a homogeneous mixture, okay? So in this topic, we'll focus our discussion on solutions that are homogeneous mixtures, as I mentioned, that are where you have two components. A solution basically has two components, a solute and a solvent. Now let me correct that. A solution does not necessarily have only two components, but at the very minimum, it has two components, okay? So it could have one solute or multiple solutes, okay? And usually there's only one solvent. The solvent is the one that's major, okay? So the one that is the most in solution is the solvent, and then the solute is the minor component. Okay, so the solute is the minor component. Now, solutions where we're going to focus our discussion on solutions where the solvent, the major component, is water. So in solutions where the major component is water, those solutions are called aqueous solutions, okay? Now, typically solutions can be described in two ways, okay? You can have a concentrated solution, or you could have a dilute solution, okay? A concentrated solution is a solution where you have a lot of the solute. So lots of solute, okay, as compared to the solvent. Lots of solute compared to the solvent. On the contrary, the dilute solution is a solution where you have lots of solvent compared to the solute. So if you want to compare them, it's going to be a lot less solute versus solvent. Now, this is a kind of a gray definition, okay, because it's hard to kind of look at one solution and say if it's concentrated or not. You always have to compare it with something else, okay? So we'll kind of go into the quantitative comparison, but just to kind of get a feel for concentrated versus dilute, take a look at an example. So let's say I give you 2 tablespoons of sugar, and I dissolve that in 1 cup of water. That's going to be a solution. It's going to give rise to a solution of a particular concentration. Let's call that solution A. And then if I add another cup of water to solution A, so you still have the 2 tablespoons sugar plus another cup of water, which may make it 2 cups water. Now you have solution B. Which one do you think is dilute? It's going to be the one that is solution B, because you have a lot more water. Therefore, by comparison, the amount of sugar is much less. So one of the key things to remember out here is you can always take a concentrated solution and make it more dilute by simply adding more solvent to it. However, you cannot take something dilute and make it more concentrated easily. Okay, so it's easy to go from concentrated to dilute, but if you try to go from dilute to concentrated, that is not easy. You can do it, but it's not easy. Okay, so one of the important ways of measuring the concentration of a solution is using something called molarity. Okay, molarity is defined as the number of moles of solute over the number of liters of solution. Now keep one thing in mind, this is not liters of solvent, it's the liters of solution. So what that means is, let's say you're taking sugar and water, you add the sugar, and let's say you're trying to get to 1 liter, you add the sugar, then you add water, stir it up, and then you top it up to the 1 liter mark. Okay, then you have 1 liter of solution. So it's the solution, meaning you're looking at solute plus solvent. Okay, so number of moles of solute per over number of liters of solution. Okay, so that is molarity. Molarity is also denoted as a capital M. Okay, sometimes you can also see this written as a capital C. C is just a standard term for a standard symbol for concentration. Out here we're getting very specific. It's the molarity, so it's capital M. And the units of molarity is simply going to be moles, MOL, over liters. So that's the unit. Let's take a look at the following problem where you have to calculate the molarity of the solution that has 40.5 grams of sodium chloride in 1.50 liters of solution. Okay, so what we need to remember is that molarity, M, is equal to moles of solute over liters of solution. So we know the liters, that's given to us. The moles of solute we do not have. We've been given grams of solute, right? So the first thing we need to do is convert grams to moles. Okay, so we need to go from grams to moles. Do you know how to go from grams to moles? You have to divide the grams by the molar mass. Okay, so the molar mass of sodium chloride, if you calculate it, ends up being 58.44 grams per mole. Now we will take the grams of sodium chloride given to us and we'll divide it by the 58.44 grams per mole. That's going to give us 40.5 grams divided by 58.44 grams per mole. That gives us 0.6930 moles. Okay, so now we have the moles. We're going to plug the moles in here, 0.06930 moles over liters of solution is 1.50 liters. And that's going to give us 0.462 moles per liter. We can also call this 0.462 capital M per molar. So that's how you calculate the concentration of something in a solution using this formula. Okay, let's explore a little deviation from this. So let's say, for example, instead of 1.50 liters, you were given 150 milliliters, 150.0 ml. Okay, the key thing out here is the 150.0 ml has to be converted to liters in order to use this formula. Okay, so all the steps will be the same. So you still go about taking the grams to the moles using the molar mass of the solute. So you'll still compute that number, which is this. And then when you divide this, you cannot use the 1.50 liters. You have to convert the 150 into liters. So if you divide that by 1,000, you will get 0.1500, liters, capital L. Put that down here, 0.1500 liters. And then divide those two, which will give you 4.62. 4.62 moles per liter, or 4.62 m. That's it. Okay, so the key learning out here is, when you're given grams, always convert to moles. Okay, when you're given milliliters, convert to liters. Okay, and only then you can use that in this formula. Okay.